Hello, this is Math with Beth, and we are going to do part two of getting ready for calculus. So if you want to freeze your screen, pause your screen, whatever, and try all of these on your own and then push play and see how I solve them, now would be the time because I'm going to fix it a little. Okay, so you can go back if you want to see all 11 questions. Um, but I'm going to start solving them now. So pause if you want to try them first. Okay, number one should be easy. Square root of 64 is 8. I'm just putting this one here to show you the difference between number one and number two. So number one, we just know because 8 times 8 is 64. The square root of 64 must be 8. But keep that in mind that that means in here there's really 2 8s. So 2 8s inside a square root is the same thing, it turns out, as just 1 on the outside. So if I confused you there, it's just to help you get ready for this. So 2 of something inside is the same as 1 on the outside. So 48 is not a nice square number, but if we split it up, so this is the prime factoring. So any two numbers that multiply to 48. So if I want to be lazy, I could start with 2 because I know it's even. So what would I get if I divided this by 2? I would get 24. So 2 times 24 must be 48. 2 is prime, so I'm just going to bring it down. Well, now I'm going to split up 24 into any two numbers that multiply to 24. So there's lots of options. I'm just going to pick 6 and 4. Again, 2 is done. 6 I can split up. Be careful, not into 3 and 3, but 3 and 2, because I need two numbers that multiply to 6. And then 4 is 2 and 2. So I've split this up as much as I possibly can. So now remember, 2 of any number inside a square root is the same as 1 on the outside. So that means these two get to come out as 1. And then there's another pair of 2's. So they also get to come out as a 2. And then that 3 does not have a second 3, so it doesn't get to come out. So I pulled out a 2 and another 2. So really I have 4 square root 3. So that's how you reduce square roots. For number 3, square root both sides, but be careful. A lot of people mess up here and think the answer is 8 because like we saw, the square root of 64 is 8. But in this case, think about it. What it's saying is some number squared gives us 64. So yes, 8 would work, but so would -8. So there's really two answers when you're doing a problem like this. So from now on, if you end up needing to take the square root of both sides of the problem, remember that's always going to give you a plus and a minus, a positive and a negative answer. So we'll see that more when we do more square root problems. All right, number 4, I'm just pointing out that if you have a square root and you square it, that really they just cancel each other out. 5 and 6 is a good example of order of operations because these are not the same answer. For number 5, because of the parenthesis, I am squaring the -4. So that means I'm doing a -4 times another -4, which is positive 16. But for number 6, that is not what this is saying. Since there is no parenthesis, what this really is like a -1 times a 4 that's being squared. So really, order of operations tells us to do the exponent first. So it is the positive 4 that I need to square. So that gives me 16, but then there's still that negative on the outside. So you have to be very careful, which is why if you're typing things into a calculator, sometimes you get a wrong answer. Because if it is number 5 that you're trying to do, but you don't use parentheses and you type it in the calculator like number 6, it's going to give you the wrong answer. So you need to be careful. All right, number 7 is just a reminder on how to get rid of that fraction. Since 2/3 is being multiplied, I should divide it to move it to the other side. But dividing by a fraction is tricky. So remember, when we divide by fractions, we really end up multiplying and flipping them. So instead of going through all those steps, you could just do it right away and say, well, instead of dividing by 2/3, let me multiply both sides by 3 over 2. And you see if you reduced, you see why that works, because the 3's would cancel out and the 2's would cancel out, and that would leave us with the x by itself, which is what we want. So now we just need to go over here and figure out how to do 4 times 3 over 2. Well, 4 is really 4 over 1. So if I write it like that, I can see that the 4 and the 2 can reduce into a 1 and a 2. And so really I end up having a 2 times a 3 on top and just 1's on the bottom. So my answer is 6. For number 8, I'm trying to solve for x, but I have 2 x's and one of them is in the denominator here. So that's annoying. So the first thing I'm going to do is move that one. So since that one is on the bottom, meaning you divided by it, I'm going to multiply by x on both sides just to move it to the other side. So x times 6 is really 6x, is how we would normally write it. All I have left on this side now that I got rid of that x on the bottom is x minus 2. So now this is just normal algebra. Since I have an x on both sides, I'm going to move the smaller x by subtracting it. Be careful, this x is gone, but that negative should still be there. And now I'm going to get rid of the 5 by dividing. And so I have a fraction, which is fine. Okay. Number 9, I put on here just to remind you that I'm squaring this. There is no shortcut. You cannot just square this and be done. So remember that 2x minus 3 squared really means I'm doing this times itself. So there's not a shortcut in that. This is foiling where you do this one times this one, then times that one, then times that one, then times that one. So I got to do all of that. So 2x times 2x is 4x squared. 2x times negative 3. Negative 3 times 2x. And negative 3 times negative 3 is positive 9. And then you can put the two middle terms together. So this would be your final answer. So if all you did in the beginning was square the 2x and square the 3, do you see you would completely miss out on that negative 12x? So that's why it's wrong. All right, number 10, I'm solving an inequality. The good news is you solve this just like you would solve a problem with an equal sign, but there is one trick. So my first step would be to subtract 3. So that's not anything tricky. But my next step is to divide by a negative. There are two things that when you're solving problems make you flip this inequality. One is dividing by a negative, which I'm about to do, and the other would be multiplying both sides by a negative. So since I need to divide both sides by -2, that's one of the 2 times that you end up flipping the inequality as you solve. So final answer, x is greater than -3. So this is totally fine, but just as a reminder, if I were to draw it on a number line, I would have an open circle and then I would show that all of my answers are to the right of -3. And if I wanted to write it in interval notation, which is where you just explain it with parentheses and brackets, it would be a parenthesis because open circle means parenthesis to infinity. And we always use parentheses with infinities. Okay. Last question, long division. Seeing if you remember long division. So I'm going to go to the next page where I have more room. If I'm doing this divided by that, this is what goes inside. Make sure you have everything less than the highest degree. So since this started with an x to the third, if I did not have an x to the second, I would put a 0x to the second there. If I didn't have an x, I'd put a 0x. And if I didn't have a number at the end, I could put a 0. But same thing out here. So since the highest out here is an x squared, since I don't have an x, I'm going to put a 0x just to hold that spot so everything will line up when I do the work. Okay. You start the long division problems by just focusing on the first terms and saying, what would you need to multiply x squared by to get it to match the 3x to the third? So it definitely need a 3. And since I only have an x squared and I want an x to the third, I would need one more x. So you pick that, and then you take that and multiply it by everything out here. So 3x times x squared, 3x times 0x is technically just 0, but I'm just going to put 0x squared just to show that that's the spot. And then 3x times 1 is 3x. So we picked the number, multiplied it by everything, and then now we're going to subtract. So I'm just going to point out that you need to be careful that you're subtracting, because sometimes it gets confusing with all the negatives. So these wipe each other out. 4x squared minus 0 is 4x squared. And 1x minus 3x is a negative 2x. And then we bring down the next term. So that's the process. You pick the number or the term that you want to put up here, multiply it by everything, subtract everything, and then bring down the next number and start again. So again, when you pick the term for up here, you're only focusing on the first terms. So what would I need to multiply x squared by to match 4x squared? Just a 4. And it's a positive 4. If it was a negative 4, I would have put minus 4. So I picked the 4. Now I multiply by everything. And now I subtract. So I need to make sure I'm really subtracting, and subtracting. These are gone. -2 minus 0 is still -2. And 7 minus 4 is 3. So the signs weren't too tricky on this one. This is our quotient. So it's kind of like the answer. This is our remainder. And if I wanted to write it all together, I would write the quotient first, plus, then I would write the remainder over what I was dividing by. So you make it a fraction. You make the remainder a fraction. And that's it for part 2 of getting ready for pre-calculus. I hope that helped. Remember to like and subscribe. See you next time.